In today's lesson, we are going to look at right-angled trigonometry. Now, this should be review because you should have covered this in grade 10, so hopefully it does come back. If not, we are going to review all the different types of scenarios that we will come across when dealing with right-angled trig. So the first thing that we want to include, even though it's not trig necessarily, we are dealing with right-angled triangles, and that would be the Pythagorean theorem, or as we may come to know it, sum of squares. And again, kind of the background to that, Pythagoras, Greek mathematician, commonly known for this theorem. However, it's since been discovered or rediscovered that he is not the first person to actually come up with this. So just kind of giving credit where credit's due. It generally is now referred to as sum of squares. But again, hopefully you recognize the formula: a squared plus b squared equals c squared. So this is actually referring to, again, the lengths of the leg or the legs and the hypotenuse. So in our example, a and b are the legs and c is the hypotenuse in our formulas. So when we're trying to find the hypotenuse, a squared plus b squared equals c squared. When we're finding a leg, it's a squared equals c squared minus b squared. Now the a and the b can be interchangeable. It doesn't really matter which one's which. The main thing is that c is the hypotenuse. So again, a and b represent the legs. C always represents the hypotenuse in this formula. With right-angled trigonometry, there are three sides to a right-angled triangle that we have to label when using right-angled trig. Now, we just mentioned a, b, and c, the legs and the hypotenuse, so we do carry over a little bit of that terminology, but for the most part, it is different. So we do have the hypotenuse. That is the same. And the hypotenuse is always opposite of your 90-degree angle. So the 90-degree angle that we have, the hypotenuse will always be opposite of that. It is also the longest side of a triangle. So when we're dealing with right-angled triangles, the longest side will be the hypotenuse. Now, sometimes depending on how the triangle is drawn, that may not be easily seen. So that's why using across or opposite of the 90 degrees is always a key way of determining the hypotenuse. The adjacent is based on the angle that you're given or trying to decide, and it is the side next to or beside your angle. The opposite is also based on the angle that you're given or trying to find, and it is the side that is opposite or across from. So it's either opposite to your angle or across from your angle. Now, we did mention that the adjacent and the opposite, those two are based on the angle that you're given or trying to find. So they may change depending on the question. The hypotenuse won't change. It's always going to be across from that 90-degree angle. So if we look at we look at this diagram here, if I wanted to label those sides, well, across from 90 degrees, because again, we have 90 degrees here, across from that 90 degrees should be the hypotenuse. Right, my hypotenuse is across from 90 degrees. Did I spell it right? I don't even know. I missed an O. Hypotenuse. So we have our hypotenuse. It's across from 90 degrees. Now the other two sides, the opposite and adjacent, are based off of this angle here. So it's our given angle. We may also see it referred to as a reference angle. But the idea is this is the angle that we're given or we're trying to find. So based off of that, the side next to it is our adjacent. Let me just change up font there just to make it all consistent. So the adjacent is beside, or is the side beside our reference angle, and the opposite is the side across from or opposite of our reference angle. Now, we did say that the opposite and adjacent are dependent on the reference angle. So if this reference angle here was actually moved up to the top, it would switch our opposite and adjacent, because then the side, this vertical side would be our adjacent and the opposite side would be our opposite. So that's what we mean when it's based on the reference angle. Now, we do need to make sure that we know how to label those sides when we're dealing with the trigonomic ratios. If you don't remember what those are, hopefully SOHCAHTOA, that term or phrase, rings a bell. That is basically referring to the different trigonometric ratios and the sides that we're using when trying to determine them. So SOHCAHTOA, SOHKAHTOA. SOHCAHTOA the S stands for sine or sin, O is opposite, and H is hypotenuse. So essentially what this is saying is that sine is equal to opposite over hypotenuse. For CAH, or CAH, it's cosine, and then adjacent and hypotenuse. So again, this is saying cosine is the adjacent over the hypotenuse. And we'll look specifically at what that means. For T or TOA, T is tan, O is opposite, and A is adjacent. So this is saying that tan is opposite over adjacent. Now this acronym is just a way to help us kind of remember what the formulas are for those ratios. You will be given that anyways, but again, it does help maybe if you aren't given them. So sine theta, again, this little symbol here, theta, just refers to an angle. So it could be an angle that we're given or an angle that we're trying to find. But the main thing here is that that's what that symbol represents. So sine theta equals opposite over hypotenuse. Cosine theta equals adjacent over hypotenuse. And tan theta equals opposite over adjacent. So the same formulas that we saw in the phrase SOHCAHTOA. Now when we're solving for angles, we do have to do what is called the inverse. So basically it is just saying, for example, sine -1, on your calculator you would just hit second function or shift depending on your calculator, and then the sign button. Because you should see above that sign button, there is a value, or it should say in smaller print, sine -1, or which is the inverse. Just keep in mind, this is not an exponent. We aren't doing sine to the power of -1. We're using the inverse. So again, that's just a button on your calculator, so it's just being comfortable using your calculator. So I do recommend using a calculator. iPhones and cell phone calculators do work, but they are a bit more of a pain to use because of how you would enter in the information. Some are better than others, but it is helpful just to stick with a calculator. So we're going to look at a couple of examples. The first one, where we have a missing side, and the variable will be on top in our formula. We're going to leave the part that's blank because that will be a standard kind of strategy that we will use to help us solve it. But we're going to save that for when we actually go through and solve a couple first, so that you try to figure out the idea of what we have to do. So with our triangle, we want to first label our sides. So we have our hypotenuse across from the 90 degrees here. We have our reference angle, so that or the angle that's given to us. So that means that 13 is the adjacent, x is the opposite. Now we have to figure out, okay, what sides am I dealing with? Well, in this case, I'm dealing with the opposite and the adjacent. So if I go back to SOHCAHTOA or my formulas, this ratio that deals with O and A is tan. So tan theta equals opposite over adjacent. And now that I have the right ratio, I can start plugging in my information. So for tan stays the same. Theta is the angle, so 32. Opposite is the unknown, or x, and the adjacent is 13. So now that I've filled my information in, now I want to try to solve for x. I want to solve for what that missing side is. Now in this case, what we would do, if we would bring up the 13, move it to the other side, and multiply. So this becomes 13 times tan 32 equals x. And if we go through, 13 times tan 32 equals 8.12. So that is the missing value there. Now, if you aren't getting this answer, but you've plugged it in correctly, you know you're entering in the formula correctly into your calculator, you're using a scientific calculator, so you know for sure that what you're entering is what we see here, and you're still getting the wrong answer, make sure your calculator is in degree mode. So somewhere on your calculator, on your screen, at the top, you should see something that says DEG, or even just D. So you want your calculator in degree mode. So that means that when we're basically, it's telling the calculator that whenever we enter an angle, it's in the units of degrees. In some cases, the calculators may use a different unit, right? There's grad and there's rad. So it's just basically different units to measure the angles, but we want to make sure that we're using degrees. So if you're getting a different answer, it could be because your calculator is in the wrong mode. Let's look at another example where the variable or the letter is on top. So again, we have our triangle. Let's label our sides. Opposite of the 90 degrees is the hypotenuse. Next to our angle is our adjacent. Across from our angle is our opposite. We want to figure out what sides we're dealing with. In this case, the hypotenuse and the adjacent. One I'm trying to solve for, one I have. So what formula deals with A and H? That would be cosine. So cosine theta equals adjacent over hypotenuse. I'm going to fill in my information. Theta is the angle, so cosine 60 equals unknown over 11. So again, we have a missing variable on the top. How do we solve this? Well, again, we bring that 11 up, we move it to the other side. It becomes 11 times cosine 60 equals x. And in our case, we should get 5.5 as our opposite length. So we've done two examples where the missing piece is on top. What have we been doing? Right? What's the consistent thing that we're doing when we're solving this? Aside from plugging information in, aside from getting an answer, what's the one step we're doing when we're rearranging? And we should find that the one thing we're doing, we have to multiply. Right? So when the variable or the letter is on top, we should be multiplying to solve. So that means we bring the 11 up and we multiply. We're multiplying our two numbers. Let's look at what happens when the letter is on the bottom. So again, we want to label our triangle. We have our angle. We have 90 degrees, so we know that this is our hypotenuse. Opposite of our angle is opposite. Beside our angle is adjacent. Figure out what two sides we're dealing with. In this case, hypotenuse and adjacent. that means we're dealing with cosine again. So cosine theta equals adjacent over hypotenuse. If I'm plugging in the information, cosine 37 is equal to 11 over x, or the unknown. Now, in the past, what we would do, we would bring this value up, we would multiply, we have x multiplied by cosine 37 equals 11. However, we don't have, or that's not going to help us solve, we still have something with that x value. So I need to move this cosine to the other side, where it then becomes division. So 11 divided by cosine 37 will give me my side length. So 11 divided by cosine 37 gives me a side length of 13.77. So how does this differ between when the variable or the letter is on top? What did we do differently? If you didn't quite recognize what we did differently, that's okay. Let's look at another example. So again, let's label our sides. We have our hypotenuse. It's across from 90 degrees. We have our reference angle of 57. Across from that is our opposite. Beside that is our adjacent. What sides are we dealing with? Well, the hypotenuse and the opposite, which would be sine. So sine theta equals opposite over hypotenuse. Let's go fill in our information. So sine 57 is equal to 10.8 divided by x. Again, letter is on the bottom, variable is on the bottom. We could go the long way, bring the x up, we get x multiplied by sine 57 equals 10.8. Bring that sine 57 to the other side, it becomes division. 10.8 divided by sine 57, x then equals 12.88. So what's the difference between when the variable is on the bottom and when the variable is on the top? What are we doing differently? Well, what's happening is we are actually now dividing. Let me keep it color coordinated. We are dividing. So when we have the letter on the bottom or the variable on the bottom, we want to make sure that we divide. Now, there is a quicker way to do this rather than switching things back and forth. Once I fill out the information, sine 57 equals 10.8 over x. Once I recognize that the variable is on the bottom, I can just switch these two entire pieces, the sine or the ratio and the angle with the missing letter. I can just switch those two spots, because that's what I end up doing anyways, and get x equals 10.8 divided by sine 57. X equals 12.88. So again, all we're really doing is taking out one step and just switching the two values. So again, you can do it that quick way when we have the variable on the bottom. When we're looking for a missing angle, we're still going to do the same thing. We still want to label our sides. So we have our hypotenuse. We don't have the angle, but we know what angle we're trying to find, which still makes it the reference angle. So that means the 11.9 is the opposite, the 10 is the adjacent. We're still figuring out what sides we're dealing with. In this case, it's the two sides that have values. So 11.9 and 10. Opposite and adjacent, so this would be tan. So tan theta equals opposite over adjacent. We're going to fill in what information we know. I don't know my angle, so I'm going to leave it as tan. Opposite is 11.9 over the adjacent 10. So how do I get theta by itself? How do I get rid of that tan? What do I do? Well, in order to get rid of that tan, what we have to do is we have to move the tan to the other side, or do the opposite of whatever tan is. And in this case, the opposite of tan and the opposite of any trig ratio is the inverse, tan -1 of that fraction. And when we do that, so again, we talked about it when we looked at the formulas, you have to do second function or shift and tan of 11.9 divided by 10, and we end up with essentially 50 degrees. Again, same thing as before, we want to make sure that our calculator is in degree mode, so when we can calculate, we get the right answer. If we get a different answer because it's in a different mode, we're still finding the right angle, it's just a different unit of measurement. But we want to stay with degrees because that's what we're familiar with. So this is what you do when you're dealing with finding the angle. We'll look at another example. Again, we see our missing angle theta. We can label our sides. We have the hypotenuse, we have the adjacent, and we have the opposite based off our reference angle. The two sides that we're dealing with, the adjacent and the hypotenuse, is cosine. So cosine theta equals adjacent over hypotenuse. Fill in our information that we have. Cosine theta equals 12 over 13. Now we're stuck at something similar where we want to get rid of that cosine. We want to get theta by itself. In this case, again, moving the cosine over, it becomes cosine -1 of 12 over 13. So the only thing that's changing between what we did in this example and the previous one, it's just our ratio. It's just our ratio that changed. Nothing else is changing. We're still doing the inverse of the fraction. So inverse of cosine, 12 divided by 13, we get 22.6 degrees is our angle. So the main thing that's consistent between the two, between the one we just did and the previous one, is that when we were finding the angle, all we had to do was use the inverse. So the inverse is this cosine -1, sine -1, tan -1. So we have to use that to help us find our angle. So all we're really doing is doing the inverse function of our ratio, and then in brackets the fraction of our two sides, or of the correct two sides that we're using. And then that gives us our answer. Lastly, just looking at some examples of using the Pythagorean theorem or sum of squares, just to make sure that we're comfortable with it. So again, remember our legs are A and B, our hypotenuse is C. The A and B don't really matter. So A squared plus B squared equals C squared. 4 squared plus 8 squared equals C squared. 16 plus 64 equals C squared. So we get 80 equals C squared. Now, that does not mean that the hypotenuse is 80. We still have to square root our answer. So let's do it step by step actually. So we still have to take the square root of 80, which will give us our actual side length. So the square root of 80 is 8.94 for our hypotenuse. And when we're going through, we want to make sure, again, remember the hypotenuse is the longest side, so that when we calculate it, we should get a longer side than our other two values, which in this case we do. So even though we may have made a calculation error somewhere along the lines, it couldn't have been too bad because we know we have a hypotenuse that is the largest side. If we're trying to find one of our legs, so again, this is the hypotenuse, or C, because it's across from 90 degrees. We can call this A. We could call it B. It's just one of the legs, so it doesn't really matter. we'll call the other one B. Again, the A and the B are interchangeable. In this case, we can use a different version of the Pythagorean theorem or the sum of squares, very similar. B squared equals C squared, or our hypotenuse, minus the leg that we're given squared. So the only difference is that we're subtracting now. So C squared is 7.4 minus 3.6 squared. 7.4 squared minus 3.6 squared. We should get 41.8. Again, that doesn't mean that that side B is 41.8. We do have to take the square root of 41.8. And we get a value of 6.47. So looking at the values on my triangle, I would say that this does work, or at least it makes sense because it is smaller than the hypotenuse. I would be hesitant to compare the legs together to say, oh, well, B doesn't look quite exactly double A, right? The main thing is, is the hypotenuse larger than the other sides, right? In this case, we see 7.4 is the largest side. It's larger than 3.6 and 6.47. So at least our answers do make some sense. So again, the main thing from this lesson is just, again, understanding or reviewing what right angle trig is, understanding how to label our sides correctly so that we can use the appropriate trigonometric ratios, trying to remember what those ratios are and what sides we deal with when working with them, as well as using the sum of squares to help us find missing sides. So all of this is just for finding sides and angles in right angle triangles. Hopefully it is review. If not, please make sure you are reviewing these concepts.